This is yet another video in Unit 2, Numbers and Science for Chemistry and Honors Chemistry. In this video, we're going to talk about measurements that we're going to be making early on in chemistry class. We're going to talk about units, the precision of the measurements that we make, and how to record the correct number of significant figures. First of all, there's an international system of units that all scientists around the world try to use. There was an international agreement that was established in 1960 that specify a particular choice of metric units for scientific measurements. Now there are 7 basic units, but I only want you guys to know the first 5 right now, because these are physical quantities that we're actually going to be measuring in the lab. One we've already measured, that's mass, and the SI unit for mass is the kilogram. Its abbreviation is a kg. For length, the SI unit is meter, and the abbreviation is a lowercase m. For time, the SI unit is the second, and a lowercase s is the abbreviation. For temperature, we'll use Kelvin, and the abbreviation for that is a capital K. And we've talked briefly about the mole in chemistry, and that's going to be how the unit that we use when we're talking about a quantity of something. And the abbreviation for mole is just MOL. The electric current one we'll use later this year. Now, if you remember, when we did our measurement lab, we were measuring the length, the width, and the height of a block of wood, but we used centimeters. We didn't use meters. Well, that centi, that little c in front of the m, is called a prefix. And there are a bunch of prefixes that we're going to be using in chemistry class. And it's just so that it will fit our numbers better, to make the numbers nice. But we're not going to talk about prefixes in this video. That's coming soon enough. Well, let's talk about mass first of all. What's the SI unit for mass? Right, kilograms, kg. Mass, and I want you to know this definition, it's a measure of the amount of matter in a substance. So we've been using electronic balances in our lab, and one electronic balance that we've used are the tiny little ones, they're called pocket balances, that were precise to 100th of a gram. We also have other balances that we're going to be using that aren't quite as precise. Length. Well, the SI unit for length is the meter. But again, for the things that we're going to be measuring in the lab, centimeter makes a little more sense. So let's have a look at the screw in this picture. If we wanted to give the length of that screw, we would, first of all, look at the measurements. They're in centimeters. What is the measurement that we're sure of? Well, the centimeters are then subdivided into 10 little graduations here. So that would be 4, 4.1, that's about 4.5, and 5. So if we look at this measurement, we see that it's 5.1, and a little bit over 5.1. We're sure that it's 5.1 and a little bit. So we're going to have to estimate the decimal after the 1. So we're going to be estimating the hundredths place. So we should report that length as 5.1, the 2 digits that we're sure of, and then let's estimate the next one. I think it's 5.12. Our final answer would be 5.12 centimeters. Now that last digit that we're recording is understood to be one that has been estimated, and we would count that as a significant digit in our calculations. Let's talk about volume. I want you to know the definition of volume. Volume is the amount of space occupied by matter. Now we've already determined the volume of a solid in the lab, and that was equal to the length times the width times the height. Now, if we were going to use the SI unit for length, which would be a meter, it would be meter times meter times meter, which is meters cubed. But again, that length of a meter didn't make a lot of sense for our tiny little blocks in the lab, so we use centimeters. So centimeters times centimeters times centimeters gives us cubic centimeters, which is the exact same thing as a milliliter. So a volume unit, liter, it's not an SI unit, but we use it very commonly in chemistry. Let's have a look at some glassware that we're going to be using to measure the volume of liquids. Here's a graduated cylinder. I want you to recognize this piece of glassware as a graduated cylinder. This is a burette. We'll be using these later in the year. It's the most precise piece of equipment that we'll be using to measure volume. And these are pipettes, and I know in biology you used pipettes, and we'll continue to use them here in chemistry class. These are called volumetric flasks. They're really good for making up solutions. And we do need to talk about volume and temperature. Volume generally increases with temperature. And so you'll see on the glassware in the lab that it will say that it's calibrated for 20 degrees Celsius. That's a pretty cool room temperature, 20 degrees Celsius. Okay, well, let's pretend that you have now just poured some water into a graduated cylinder and you would like to report the volume of the water. Well, there's a problem. How do you read the volume? There is this curved line here. So if this is the walls of our graduated cylinder, and here is our liquid right there. And see how it's just not a straight line across? This concave curve here of the liquid at the surface is called a meniscus. The reason it happens is because of surface tension. The water may be more attracted to the walls of the container than it is to itself. And so we get this meniscus showing, especially if the glassware is clean. Well, where do we read the meniscus? You always read to the middle of the meniscus. Most liquids give you this concave meniscus. Mercury, but we're not going to be using it this year or ever because it's toxic. It has a convex meniscus. But for us, we're going to be seeing concave meniscus, and we're going to read right in the center of it. And so we're reading to the bottom of the meniscus. And how do you read that meniscus? Your eyes should always be eye level with the bottom of the meniscus. So if we're looking at this graduated cylinder and we're reading to the bottom of that meniscus and our eyes are eye level with it, and that's why you'll see a lot of scientists kind of stooping over to take a measurement. It's not that their eyesight's terrible, it's that they want to get a correct measurement. Well, let's get the volume of this. I know for sure that that's 30 milliliters. Every line here is 1 milliliter. That's 35. It's 36. 36 milliliters for sure. I think it's closer to the 37 than the 36. We're going to have to estimate that tenths place. It's 36.6 milliliters. That's how I would record my volume. Again, notice that we record what we know for sure. We know for sure it's 36 milliliters and a little bit. And I was estimating that it was closer to the 37 than the 36. So I said 36.6. All right, precision in glassware. You know, you pay a lot of money to get precision. And so always make sure that you write down your measurement as best that you can. You're always going to record the measurement to the decimal place that you're sure of, plus one more that you've estimated. We're going to practice measuring lengths and volumes in the lab tomorrow. So I hope you paid attention and you filled out your guided notes, and we'll see you then.